Hello everyone, in this video we'll be talking about the coupler curves and how to generate them. In the class I have already discussed with you how to create this coupler curve. I have taken a 4-bar mechanism with a point E which is displaced from the joining points BC, and the angle of this link is given as alpha along with all the important measurements. So the link AB length has been given as A, which I have marked here. The length of link B, which is this point, the length BC has been marked here, and the length C, which is the length CD, is here, and the length D, the final link, which is the frame, is of length D, and this length BE over here is of length E, small e, and the angle between the link length BE and BC, actually BEC is completely one single link, and the angle between the lines joining BE and BC, that angle is alpha, and theta is the angle which this crank AB is making with the frame AD. Now this angle theta keeps varying, so as angle theta changes, the point E will travel on some path, and this path, I had told you clearly, that path is called as the coupler curve. The link BEC is the coupler, and any point on this link BEC which travels on a path, that path is called the coupler curve. So here we had found the formula for finding the coordinates of this particular point E. XE is the x coordinate and YE was the y coordinate. So we derived those lengths using these formulae. A little bit of trigonometry we had used, and we were able to find the formula for this. Now if you see this formula, it has A, which is constant, theta, which is here varying. So for each value of theta we are supposed to get a value of XE, and here E value is known, of course it's constant value, length of these points, the length between these points B and E, and we have two angles here. Alpha angle is of course the angle on the linkage, so it's not going to change, whereas beta, the small angle which you see here, the angle of BC, the angle of line joining BC with the horizontal, that angle is beta here. So that angle of course is going to change. So we had to find the angle beta using another formula. So we took this triangle BDC, and in that triangle we applied the law of parallelogram, and we were able to find the sum of these two angles, beta plus gamma. Now if you want to find beta with this equation, you are supposed to actually know gamma beforehand. Now gamma is again one of the unknowns, so we went on to find the value of gamma using this particular triangle BMD. So we were able to find it like this, and this is the formula for gamma. So in this, of course, all the values are known, so we can find the value of gamma first, then using the value of gamma we can find the value of beta. Beta again we can substitute here to get the values of the coordinates. Now doing that manually is going to be very difficult, so I have thought out another method of using Google Sheets to do this automatically for us. So I'll have to feed these formulae into the equation one by one, and that equation will allow us to do all the calculations. So first of all, gamma we'll have to find, so I'll have to feed these values. So I'll just start with equal to, and then you have to continue putting in the rest of the formula. For gamma, that formula is going to be here, so we'll have to take tan inverse. So I can just type A tan, and you can see here inverse tangent of the value in radians is going to come out. But here the angles that we have fed is in radians, so we'll have to first convert it's in degrees, so we'll first have to convert this into radians. So to do that, I'll just have to give command of radians. So this will convert the value in degrees to radians, and the tan inverse. Okay, the tan inverse. So actually the angle in radians is going to be required only for theta, so we'll just have to take A value first. So just after A tan bracket, I'll have to select A, and then I'll have to multiply with the sine of that angle. So I'll have to take sine of the angle provided in radians. So then I'll have to convert the angle into radians. So the angle required here is theta. So yeah, theta angle. So I'm converting this angle in degrees into radians, and then finding out the sine of that, multiplying it with a value over here. And then I'm closing the brackets. So this bracket close is for radians. Another bracket close is for the sine of angle. And then I'll have to go into the denominator. I'll have to take divide. And I'll have to open and close another bracket. So this complete thing, whatever we have here, it's going to come in this bracket. So next value that we want is d value. So d value minus a value again multiplied with cos of theta. So I'll have to take cos, and then I'll have to convert the value to radian. And the angle that I want is theta, so theta. And then I'll have to close the bracket. So cos value is closed, and cos angle is also closed. Then this bracket will have to close it again. So I'll just have to put another one. So the complete bracket is closed of the denominator. And okay, we'll have to just be careful with how many brackets are opening and how many are closed. So this starting bracket is not yet closed, so we'll actually have to close that over here. Right. So we'll have to be extra careful while closing brackets. So this open bracket is here, and this bracket is still single, so we'll have to close that over here. Fine. So we have got the value, and this value of gamma, it is still in radians. So we'll have to convert it back into degrees. So just before a tan, I'll have to type degrees. Okay, so just give a gap over here and type this degrees. So converts the radians to degrees, and this complete value I'll have to convert it. So now that we have the value, I'll just reduce its decimal places to convert it around 1. Okay, so this is the value of gamma. You can see the formula is very, very big one, and we have to be very careful with calculating the formula. Let me confirm whether this value that we got in the class is the same that we got here. So the gamma value we're getting 24.8. Okay, so you're using calculator, so you must have used some rounding off, which has actually diverted the value. I've used the values directly over here, so this value here that we're getting has got to be more accurate than what you calculated using your calculators. Next up, we'll have to find f. The formula for f is over here using the Pythagoras theorem. So just take equal to square root, bracket is opened. I'll just put the closing bracket as well around here so that later there is not going to be any confusion. And now I'll have to take another bracket open and raise this power to 2. Inside the bracket we have a, so I'll have to choose a value. Multiply this with sine, sine of angle. So I'm just closing the brackets whenever I'm opening it already, so that there's not going to be confusion. So a value multiplied with sine of the angle theta. So now when I'm taking theta, I'll have to take the radian value of it. So first convert this to radian, close the bracket for radian, and then radian value of theta. So this is the value in degrees, which will be converted to radians and will be used for calculation. So yeah, so just before the last bracket over here, inside of that I'll have to use a plus sign and another bracket, open close, power square again. So inside this I'll have to put in this value. So we have d, and then we have minus, then we have a, and we have to multiply this with cos. I'm closing the bracket of cos here itself, and then I'll have to take radian value. I'm closing that angle as well, and the radian value of theta is what I need. So this is the value that I want. So once again I'll just reduce this, the number of decimals after the point, I'll reduce it. Let us check whether we have got the correct value. F value is 61.96 that you calculated in the class. I'm getting 62 of value. So okay, next we'll have to find beta. So the formula for beta is somewhat like this. Okay, it's quite complicated, I would say. So we'll have to take cos inverse. So press equal to, and for cos inverse I'll have to take a cos. A cos is going to provide me a cos inverse of all these values. So let me take a bracket for the numerator and a bracket for the denominator. I'll also close the bracket for cos. In this bracket I'll have to type in the numerator. So the numerator is b square plus f square for b power 2 plus b square plus f square minus c square. C values here, c power 2. So numerator is clear. Now I'll have to go for denominator in this bracket. So you have 2 into b into f. So that is in the denominator. So this complete value will be calculated as the value for cos inverse. So cos inverse of this, we are getting this value in the form of radians. Next, what we'll have to do is we'll have to subtract gamma from this. So first of all, let us convert this into degrees. So degrees and then bracket. So this complete value I'll have to convert to degrees, and then from that I'll have to subtract the gamma value in degrees. So that will give me the value of beta in degrees. So yes, beta value in degrees, it's coming fairly correct. 65.59 is the value you got here, and I'm getting 64.5. Lastly, we'll have to find the value of xe and ye. So that's, I don't think it's going to be much more difficult. So I'll have to type a equal to, then a multiplied with the cos value. So after taking cos, of course, I'll have to convert this to radians, and the radian value of theta I'll have to take. Close the bracket for radian and close the bracket for cos. And now we'll have to add to this the value of e multiplied with cos of an angle. So we'll have to again convert this to radians, and radians, we have to take the sum of two angles, that is the angle of alpha plus beta. So alpha plus beta, where is beta? Beta is here. And close the one for radians, close again for cos. I think that's it. These are all the brackets closed. So this is the value of xe. I'll just reduce the decimal values. Let us check whether we have got the correct value. 35.8 is what I'm getting. You got 35.23. It's okay. It's fairly okay. So next, I'll just take the same formula. I'll just copy the same formula, and I'll put it here for y. So the only difference I have to make is, instead of cos, I'll have to take sine. So let me just change cos to sine, and I'll be okay with that. So I've got 54 point something. Okay, 54 point something. So you got 53.89, 54.5. So fairly okay. So now, why we did all this is because we just have to struggle with it once. Once all these formula have fed, next thing is just dragging. So I can just go on to drag these values, and I can just go on to, vary the values, 30, 60, and so on. And up to 360 degrees, I'll be able to get all these values ready-made to me. I'll just delete it. Fine. So all the 12 values are there. So these are the input values for which I have to do the same calculation. So all I have to do is I'll have to select them, and holding this point over here, I just have to drag them down. And all these values are readily available to me. Fine. So xe and ye values, all these values are ready. Next step is that we'll have to point these values and check if the point E indeed is passing through all this. So that we will see in our next video, wherein I'll be using some other CAD software to draw the linkage, mark all these points on the mechanism, and see whether all these are passing through, that the point P, E, if it is passing through all those points. Thank you for watching this, and if you like this, of course, just give it a like, hit the like button, and subscribe to the channel for keeping yourself updated about all our future videos. Thank you once again.